Hi and welcome to our mathematics class. In this particular session, I want to deal with the introduction to statistics. Introduction to statistics. So this is session number 2 of our Zika DA2 and Zika 1.2 classes. So introduction to statistics. This chapter specifically will deal with the general awareness and understanding of the collection and presentation of numerical data or information, including the frequency distributions. We are also going to tackle a bit on the data analysis, that is the measures of centrality, the mean, mode, and median. That will be the part we'll be dealing with in this particular session. At the end of this session, students should be able to analyze and interpret at least the basic statistics or statistical data. So statistics can be categorized or classified into 4 parts. The first part deals with data collection. The second part deals with data classification. The third part deals with data presentation. And the last part, which of course is the biggest part of our statistics, this part deals with data analysis. And under data analysis, we have statistical measures. Statistical measures. So these are measures of centrality, mean, mode, and median, measures of dispersion, and measures of skewness. In this particular session, we'll introduce the measures, the statistical measures. That is, we are going to look at measures of centrality. So let's start with the first part. First things first, data collection. Now, data can be collected from different sources, and the major sources of data for any organization is either data is coming from internal sources, that is, the records that an organization keeps, the reports that are generated within the organization. As long as data is coming from within the organization, we call that internal source of data. External sources of data, this is where an organization can get data from outside itself, that is looking at probably government magazines, business reports in the industry, the Central Statistics Office for the government. All those can be sources of data for the organization. But as long as data is coming from outside the organization, we call those as external sources. Let's talk about sampling. Sampling is simply a process of picking a sample from the entire population, and a sample can be explained as a part of a population in which the population characteristics is studied so that inference may be made from the sample to study about the entire population. The reason why we pick samples is that we may want to examine these samples, and so that the results we get from the sample will at least give us ideas of what we expect from the entire population. The question is, why sampling? Why use samples? We use samples because it's easy to deal with the sample, analyze the sample, than analyzing the entire population. Secondly, it's cheaper also to analyze the sample than analyzing the entire population. There are different methods of picking a sample. These are called sampling methods. Now, sampling methods might be random sampling methods. Random sampling method is where there is no biasness in the way you're picking the sample, so you're picking the samples randomly. Non-random sampling is where you're following a particular or systematic way of picking a sample, and this is quite biased. There is biasness in the way you're picking samples. Now the question is, which one is more important than the other, random sampling or non-random sampling? What is important here depends on what you want. For example, if we are taking opinion polls, we may use random sampling, just pick individuals at randomly because you just want to look at which president probably is more favorable in a given location. But if you are picking an interviewing panel, you need to select people who have specific qualifications, specific skills, and things like that. So you're going to use non-random sampling. So it will all depend on what you need. Let's look at what a frequency is. What is a frequency? If in any population you have two or more members that have the same value, then you have a frequency. Because frequency simply means the number of times each value is appearing in the distribution. That's the frequency, number of times each value is appearing in a distribution. That is the frequency. So if you have values that have got more than one, or two or more members that have the same value, you have some kind of a frequency. These members or these values are appearing more frequently, or they're appearing more than one time in the distribution. So let's look at an example of a frequency distribution. So we have a frequency distribution where we have 0, 1, 2, and things like that. We've got numbers in the distribution. So the following data is a record of the number of children under the age working in a certain company. Children under a particular age working in a certain company. So we have 0, 1, 3, 2, 0, 8, 8, and the numbers continues like that. If you have a distribution where values are not arranged in any particular order, you've got raw data. But if this data is arranged in a particular order of size, whether ascending or descending order of size, you have a data array. So what is the data array? A data array is simply data that is arranged in order of size. And this order may be ascending from the smallest to the largest value, or descending from the largest value to the smallest value. So when we do a data array of this distribution that we have here, a data array will look like this. That's how a data array will look like. So we have 0, 0, 0, 1, 1, 1, 1, then 2, 3, and 4, 4, 6, 6 going up like that. From this data distribution, you can also construct a frequency distribution. Now, a frequency distribution, you show the number of children under age and the number of those children who are under that particular age. So the number of times each of these values, which is the age, is appearing in the distribution, that number of times is going to be the frequency. So for example, 0 is appearing 3 times, so the frequency for 0 is 3. 1 is appearing 4 times, so the frequency for 1 is 4. 2 is appearing 2 times, so the frequency for 2 is 2. 3 is appearing only once, so the frequency for 3 is 1, and so forth and so forth. So the frequency, you're just looking at the number of times each of those values is appearing in the distribution. Now, in the case where you have the number of distinct data values in a set of raw data, where you have this number of distinct values that is large, meaning that you've got more than 20 or 20 or more, you can't use a simple distribution in your frequency distribution. In that case, you are going to use grouped data. You are going to group data. For example, you can group data in sets of 5. For example, 5 to less than 10, 10 to less than 15, 15 to less than 20, 20 to less than 25. And then you count all the values that are falling in that particular class. So for example, all values between 5 and 10, you count them. If they are 5, then you're going to have 5 like that. This is just an example of a grouped frequency distribution. Let's move on to the next thing, data classification. Data classification. Under data classification, you have classifications such as primary and secondary data. Primary data is data that is collected for the original purpose of a survey. Secondary data is data that is used for other purposes other than the original purpose for which the data was collected. Qualitative and quantitative data. Qualitative data, this is data that cannot be expressed, or data for which it is difficult to express it in numbers or countable values. Why? Because qualitative data talk about attributes, things like skin color, gender. You cannot express such information in numbers. Quantitative data, this is data that is easily expressed in countable variables. Number of people, the height, uh, the weight. You can express all that kind of information using numbers. Now, quantitative data is the data we are concerned about in statistics. We are not concerned about the qualitative data because we can't express that data in figures or numbers. So we are quite interested in quantitative data, from the word quantity meaning countable data. Now, that quantitative data can further be classified into discrete data and continuous data. The difference is this. Discrete data, this is data that is expressed in absolute numbers. Data expressed in absolute numbers. Things like number of people, where you cannot have decimal places, that is discrete data. For example, if you're talking about number of people, it's not possible that you're going to have 5.7 people. It's either you have 5 or you have 6 people in the group. You can't have point something number of people. So that is discrete data. Continuous data is data that can take on any variable. Data that can take on any variable. Things like height. Height is continuous data because you can have decimal points when you're uh, measuring the height, measuring the word, time, things like that. You have decimal points. You can have 10.7, 10.8. But for the number of people, you can't have decimal places. So number of people, that's discrete data. Height, weight, time, that's continuous data. So let's move on to our next item on data presentation. Data presentation simply talks about different ways of presenting data, different ways of presenting data. The first way of presenting data is using tables. Using tables. This is called tabulation. So tabulation is just a process of putting data in tables. And in statistics, we believe that when data is presented in tables like that, it becomes easier for the users of information to understand, easily understand information, and information is well summarized when it's put in a form of tables. So tabulation is one of the ways of presenting data. Second way of presenting data is using bar charts. We have different types of bar charts, and the first type that is shown on the screen here is called the simple bar chart. So you have bars presented like that, and simple bar chart has bars that are non-joining. So the bars are not attached to each other. The bars are quite separated. These bars in this particular example is showing sales in millions that were achieved in the following years given. The second way of uh, uh, presenting, or the another type of bar chart is called the component bar chart. Now the component bar charts are used to show the breakdown of the total into components. For example, we had total sales achieved in 20x3 represented by that particular bar. Now If we are talking about a company probably that is selling 3 different products, you would love to know how much of these sales can be accredited to a particular product. This is where now component bar chart comes in, because in a component bar chart, you divide or break down that total sales into components as shown in the graph that we are looking at here. What is important is when you do a component bar chart, you must have a key, something like this, to indicate what each component represents. So the white space there represents West Africa. Probably this is West Africa sales. The one that is in blue represents South Africa, and so forth and so forth. Now, we can present component bar charts in 2 ways. Number one, it's a component bar chart that reflects actual values. Secondly, you can do a component bar chart that reflects percentages of the value. So we have the percentile bar component bar chart and just the component bar chart that shows actual values. So the next one there is sales are shown as a percentage of the total. So if you're showing as a percentage of the total, of course, you have to go up to 100%, which is the maximum you can ever have. The other type of bar chart is called the multiple bar chart. Unlike the component bar chart where you're showing components within each bar, multiple bar chart, you show those components as separate bars. As we can see, 20x3, we have 4 different separate bars. Instead of showing one bar and we have those components, we show each component as a separate bar. That's a multiple bar chart. An histogram is in the category of bar charts, but this histogram, these are bar charts where the bars are joined together. We call it an histogram. Simple bar chart, we have bars that are separated. They are non-joining bars. In an histogram, you have joining bars like this. So if you look at the graph we are referring to, there is no space between the bars. So that one is called an histogram. These bar charts we had on top here, let me just go back and show you that simple bar chart. You notice that the bars are non-joining. There is space between the bars. It's called a simple bar chart. But where bars are joined together, we call that an histogram. Now, an histogram can also be used to determine the mode. Mode is simply the value that appears more frequently. That's the mode of value. The value with the highest frequency. That's a mode of value. So an histogram can be used to determine the mode graphically. We know that the tallest bar is going to be the model class. The tallest bar is going to represent the model class, which means that the mode value is found within that model class. But how do we determine this mode value? If you are using a graph to determine the mode, all you have to do is draw diagonals across the ends of the bar chart. Of course, you have to locate the tallest bar, which will represent the model class bar. Then do the diagonals where the diagonals intersect. There you have the mode value. So the mode value is the value down there where the diagonals intersect. So you can use the histogram to determine the mode value of the distribution. The next data presentation uh, uh, method is using a pie chart. A pie chart is a circular chart. Uh, the word pie simply means the pies that people used to create. But in those days, pies were made circular. Nowadays, pies are made triangular. So when you say pie chart, people nowadays may fail to relate clearly to what kind of pie chart we're talking about, because we have got triangular pies nowadays. But in those days, pies were made like chapats. So somebody thought of this kind of circular presentation of information as a pie chart. Now, this pie chart is simply divided into sectors, which represents the components of the total. And we know that the total degrees for a circle is 360 degrees. So if you're using degrees, you use 360 degrees to represent the total of the degrees in a circle. If you're using a percentage, it has to go up to 100%. So this is an example of a pie chart. If you want to do the calculation, actual calculations, all you have to do is add up the total sales, and those total sales, of course, are going to be equals to 360. If you are using the degrees, all the total sales are going to be equals to 100% if you are using percentages. Then how do you calculate for each sector of your pie chart? This is how you do it. So West Africa, if West Africa has got 82, so you say West Africa has got 82, whatever sales out of the total multiplied by 360 degrees, you'll get the degrees for West Africa. East Africa, if it's got 41, it's 41 out of the total, multiplied by 360 equals 72 degrees. If Southern Africa has got 20.5, it's going to be 20.5 out of the total number of sales or sales volume multiplied by 360. So we are multiplying by 360 because we're measuring the sectors in terms of degrees. If you are measuring in terms of percentages, you will multiply by 100%. Now let's come to data analysis, which is a crucial part in our statistical study. Data analysis. Data analysis, we've got three parts under data analysis. This is a measure of centrality, and which is also called measures of location. These are simply averages, the mean, mode, and median. Measure of dispersion includes the range, interquartile range, standard deviations, variances, mean deviations, and the coefficient of variations. All those are measures of dispersion. I'm going to deal with the measures of dispersion in our part 2 of statistics, but in this part 1 of statistics, we're just looking at measures of central tendency, or measures of centrality, or measures of location. It's one and the same thing. And of course, we'll look briefly at the measures of skewness. Now, let's consider measures of centrality or measures of central tendency. This is the mean, median, and mode. And we go straight to look at the example. First of all, before we go to the example, let me explain what this means. The mean is simply an average. It's calculated as the sum of the values divided by the number of values. Median is the value that is found exactly halfway in a data array. So what you need to do when you are calculating the median is to arrange data in order of size and then pick the value that is exactly halfway. Mode is quite easy to get because mode is just the most frequent value in the distribution. All the value that has got the highest frequency in the distribution, that's the mode. So we have the mean there, and we have an example there, which is consider the following prices of a packet of milk from 12 different retail outlets. So we have those prices from 12 different outlets. What's the mean price? So the mean price is simply the sum of all those values. You had 280 plus 275 plus 290 plus 310 plus 185 plus 195 plus 200 plus 225 plus 175 plus 200 plus 190 plus 195. When you get the sum of those, you divide by how many they are. They are about 12 values. So the sum divided by 12. So this is what is happening here. You add all the values divided by 12, you get 255. So 255 is the mean price, or it's an average price amongst the 12 shops or stores. So the formula for calculating the mean of a simple set of values is going to be mean equals to the summation of x divided by n. This is the formula that we use to calculate the mean of a simple set of values. Mean of a simple set of values. Look at this. This is a simple set of values. Data is not put in a frequency distribution. It's just a simple distribution that we have there. And this is the formula that we apply. And then the formula This as, this is a Greek symbol for capital S, which just represents time anyway. It represents you are adding up all the values of x and dividing by n. Next mode of a simple frequency distribution mode is that's the number which appears more times in any distribution, the number that appears more frequent in the distribution. So if you refer to the distribution we're talking about here, just look at the distribution and identify which values are appearing more frequent than the other values. You will notice that we have now 195 and 195. 195 is appearing twice. We have also 200 and 200 appearing twice. The rest of the values we have also, no, this is 290, this is 190, so they are not the same values. So we have 200, 200, 195, 195. These are the only values that are appearing twice. The rest of the values are appearing only one time. So we have two values that are appearing more frequent in this distribution. So our modes are two values. Our modes are 200 and 195. Those are the modes that we have in that distribution. The median. Median is the value that is found exactly halfway in the distribution. So what you need to do before you pick out the median value, you have to arrange data in order of size or do a data array. So the data that we have on top here arranged in order of size, you can start with the smallest to the highest value, which is ascending order, or you can do the descending order from the highest to the lowest value. So the highest value we have is 310, I think, followed by 290. Then we have 280. Then we have 275 and things like that. So arrange the data in order of size, descending order. You have that particular order. Then from that order, the next step is to find the position of the median value. How do we get the position of the median value? You do n plus 1 divided by 2. That's the position of the median value. N plus 1 divided by 2. So look at that. N plus 1 divided by 2. N is the number of values we have there. How many values do we have? Obviously, we have 12 values. Remember, this data is coming from here. That's the data we're looking at. So we have 12 values. 12 plus 1 divided by 2, that is going to be 13. 13 divided by 2, we have something like 13 divided by 2, we counted 11 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we have a total of 11 values. 11 values. So 11 plus 1, 12. 12 divided by 2, we have the sixth value. The sixth value. We have the sixth value. So the sixth value is going to be the median. So when you arrange the data in order of size like that, you should count up to the sixth value. So 1, 2, 3, 4, 5, 6. The sixth value should be our median value. That's how we calculate the median, mode, and mean for a simple set of values. What about the mode, median, and mean for grouped data? For grouped data, we have an example here. We have data given, age given, and the number of employees. Age is our data, and then the number of employees, this is our frequency. That's our frequency. It's just the number of times, number of employees we have in that age category, which represents the frequency. Now the questions are: find the mean, find the median, find the mode. So what's the mean? The mean of a frequency distribution is calculated as summation of fx, summation of fx over summation of f. So we get the data, we begin to create fx values. So this is the data, that's a frequency given. That's the data given. This is coming from the data you are always provided with. That comes from that data. picked into our solution. That's the data that we have. So all we are looking for is fx. According to the formula, we need to get the frequency multiplied by the x value. Now that we are given a grouped data, how do we get the x value? The x value is simply the midpoints of the data that we have. So we create a column where we can calculate the x value. And the x values are, what's the midpoint of that class? 15 plus 19 divided by 2, that's the midpoint. It's going to be 17. 20 plus 24 divided by 2 is going to be 22. 25 plus 29 divided by 2 is going to be 27. 30 plus 34 divided by 2 is going to be 32. 35 plus 39 divided by 2 is going to be 37. So our x values are simply midpoints that we are getting. Now we get fx. According to the formula, we need fx on top, the sum of it. So fx is the frequency multiplied by the x value. So 3 multiplied by 17, 3 multiplied by 17, 51, 15 multiplied by 22, 330, 30 multiplied by 27, 810, 45 multiplied by 32, 1440, 8 multiplied by 37, we have 296. You can actually do the actual calculations of these figures and find the solutions. All right, now that we've gotten our fx column and our f column is there, the summation of f is what we need for our denominator, and the summation of fx is what we need for our numerator. So you add all these values, add those values, you get 2927. Add those values for f to get the summation of f. So what we need, what we have there is actually the summation of f. And what we have there is the summation of fx. So picking those figures, put them into the formula, mean equals to summation fx, summation f. So summation of x, summation f divided, the mean is going to be 28.98. That's the mean for that data. What about the median? The formula for calculating the median is given as the lower boundary of the median class plus, open brackets, 0.5 of n. N represents the number of values, and that number of values is the summation of f. Then minus cumulative frequency of a class immediately before the median class. Please take note, when you see a capital F, it stands for cumulative frequency. But it is cumulative frequency, you're getting the cumulative frequency of a class immediately before the median class. Then down there, denominator here, you have the actual frequency of the median class. And C there represents the class width. That's what we have in our formulas. Now, let's pick the median. Remember, we said for you to pick the median value, first of all, data must be arranged in order of size. Do a data array. We already have a data array here, and data is arranged in ascending order. We are starting with 15, ending with 40. There is a data array already. So the next thing we need to do is to find the position of our median class. Once we find the median class, then we can calculate the median value from the median class. So how do we get the median class? The next step, apart from just ensuring that data is in order of size, which is always going to be the case when you're dealing with grouped data, the next thing you need to look at is create a cumulative frequency. So what is a cumulative frequency? It's just an addition of frequencies. So for example, the frequency was 3 here, the frequency 3. So this 3 plus the next frequency 15 gives us 18. 18 plus the next frequency 30 gives us 48. 48 plus the next frequency 45 gives us 93. 93 plus the next frequency 8 gives us 101. It's the cumulative frequency. Now let's find the position. The position, remember what we did with the position? It's the summation of f, which is 101. Of course, if you get summation of f plus 1 divided by 2 or multiplied by 0.5, it's going to give you something like 50 or 51. So in this case, we are using the decimal points. We get 50.5. You can as well round it off to 51. So 50.5, you come back to your cumulative frequency and see within which value 50.5 is going to fit. What this 3 here on your cumulative frequency means is that we have all the values that we have between 15 and 20 are just 3 values. The fourth value is coming from 20 to 24. So we have the fourth up to 18th value all coming from 20 to 24. Then we have the 19th up to 48th value all coming from 24 to 30. And then we have the 49 to 93. So if you're thinking of 50.5 or 51, you're going to get that value within that figure. So the median class is going to be 30 to 35. The median class is going to be 30 to 35. So once you identify the median class as 30 to 35, that's the median class identified from the question. You can now apply the formula. So let's look at the formula. The formula is lower boundary of the median class 0.5 multiplied by n, which is summation of f. So this is going to be 101 minus the cumulative frequency of the class immediately before the median class, actual frequency of the median class, and the class with it. Now let me show you how to pick these figures. Let's start with the cumulative frequency of a class immediately before immediately before the median class. So let's go to our data. Find the median class. The median class is this. That's the median class identified. Then go back. The class immediately before the median class is 20 to 30. And the cumulative frequency for that figure, for that class, is 48. I'll come again. Median class is this one. Class immediately before is that one. Then get the cumulative frequency of that class, 48. So the capital F m minus 1 is going to be 48. Now this one, denominator there, is just the actual frequency of the median class. So go back to your table. The median class is this one. The actual frequency of the median class is 45. That's how we're picking 45 there. So what remains now is just to put in figures. Lower boundary of the median class. Median class is 30 to 35. So the lower boundary of that class is 30. The upper boundary is 35. The class width is 35 minus 30, which is 5. So C is going to be 5. Substitute those figures here. 0.5 multiplied by 101, it gives you 50.5 minus 48 divided by that. When you calculate, you get 30.2778, and that's the median. Let's look at the mode. How do you calculate the mode? I've said one of the ways to calculate the mode is to use a graph like we showed that graph on the histogram, but the other way of getting the mode is by using the formula, and the formula is mode equals to the lower boundary of the class plus open brackets d1 d divided by d1 plus d2 multiplied by g. d1 is the difference between the model class frequency and the class immediate and the frequency immediately before it. d2 is the difference between the model class frequency and the frequency immediately after it. I'll show you how to pick those figures. Then G is the class width. So what we need to do first and foremost is to identify the model class. Remember the way we describe the mode. The mode is that value that has the highest frequency. So let's go to the model class and check from the table. The model class should be the class with the highest frequency. And in this case, the class with the highest frequency is 45. So the model class is 30 to 35. Now again, for the median class, we got 30 to 35. This is not always going to be the case. There are different ways of getting this, but in this case, we are getting the same class because the class with the highest frequency happens to be the same class that is found halfway of the distribution. It's the median. So the model class is 30 to 35. We've gotten that one. model class 30 to 35. So we have model class 30 to 35. So the lower boundary is going to be 30. The class width is going to be 5. Now let's get the D1 and D2. D1, we said this is the difference between the model class frequency and the frequency immediately before it. So we have the model class frequency 45, and the frequency before, immediately before it is 30. So that's why we have 45 minus 30 here. 45 minus 30. The difference between the model class frequency and the frequency immediately before it gives us D1. Then denominator here we have D1, which is the same as 45 minus 30, then plus D2. D2 is the model class frequency minus the frequency immediately after it. So just check it from our table there. Model class frequency 45, the frequency immediately following it or after it is 8. So for the D2, we are going to have 45 minus 8. So we have D1 45 minus 30, D2 45 minus 8. Punch those figures into your calculator. Your mode value should be 31.442. Now, finally, in this particular session, let's look at the relationship between these measures. Now, if you have a situation where the mode value is higher than the median higher than the mean, then you have some kind of skewness. And this is called negative skew. Negative skewed. Your distribution is going to slant towards the left, where the mean is. The median is always going to be in the middle, and the mode is always going to be the part that has got the peak on it, because the mode represents the frequency, the value that has got the highest frequency. Where you have a situation where mode, median, and mean values are the same, you've got a symmetric curve. You've got a symmetric curve, and this is called normal distribution. That one is called normal distribution. Normal distribution. That's what we call that one. So when the distribution is normal, it means the median, mean, and mode are all of the same value. And put it in a graph, you have a symmetric graph. And in this symmetric graph, you have a probability of 0.5 on the one half and 0.5 on the other half, meaning that the entire area under that curve is going to be equals to 1. Then the right skewed or positively skewed is where the mode is lower than the median lower than the mean. So after this video, you're supposed to go straight and watch the video on normal distribution and how to calculate those values on normal distribution. So thank you so much for your time. I'll see you again in the next